Okay, so our topic for today is about two-sample z-test. No? So the two-sample z-test is used to compare the means of two samples to see if it is feasible that they come from the same populations. So the null hypothesis is the population means are equal. So the z-test is prepared to the t-test for large samples. No? N is greater than 30, or when the variance is known. Otherwise, the sample standard deviation is a more biased estimate of a population standard deviance than is allowable. And using a two-sample t-test should be considered. No? Okay, so I will show you an example of a two-sample t-test using Microsoft Excel.
This is Masti Bardi for HAP 501 at George Mason University. I'd like to show you how to use Excel to conduct a two-sample z-test. Now, why are we using a z-test here? We have an example of salaries for registered nurses and non-registered nurses, and we'd like to compare them to see if there's a difference between the salaries of these two groups. Now we can only use a z-test when we're comparing two sample means if we know the value of our population variances, or if our samples are large enough that we can substitute the sample variance for the population variance. In this case, as I mentioned, we have 32 registered nurses and 34 non-registered nurses. So because both samples are larger than 30, we can assume they're large enough and substitute our sample variance for population variance, and therefore run a z-test that assumes that the population variances are known. So, okay, the first step would therefore be to calculate the variance of our samples, and for that you can either use the summary statistics functions that you're familiar with, or you can just use the function key and simply calculate just the variance. Here is the function you need, VAR for variance. Say OK and choose the range of values for the first sample, registered nurses, from A2 all the way to A33, because we had a sample of 32, and say OK. And here's the value of variance for our first sample. Now for the second sample, we do the same. We choose the function key, statistical, variance, say OK, and this time we choose the values from B2 all the way to B35 for our sample of 34. Say OK. And now here we have our two variances for our two samples. So therefore we can use the two sample z-test. How we do that? Go under Tools, Data Analysis, choose the z-test two sample for means. Let me move this here. Say OK. And again, let me move this here so you can see it. So our variables in range 1 are our first sample. Let me go up a little so I can choose the label. Here we go. Our variables for sample 2, this one. Say OK. You can either put 0 here for hypothesized mean difference, or if you leave it blank, Excel will assume a 0. In this case, we're interested to see whether the means are different or not different. So 0 is the value we're interested in. I'm just going to leave it blank. And then I have to enter the value for variance for our first sample, which is this one. So I'll just type it in, 264.1638. And the variance of our second sample is 166.4095. I had chosen the labels category, so I'll mark that, and then I will ask for the output to be put right here so we can see it, and say OK. And here it is. We have, let me increase the width of the column so we can see properly. So here Excel has run a z-test for 2 sample for means. It indicates that the variances are known, and using these values, number of observations in each sample, the registered nurses and the non-registered nurses, and the test statistic, the calculated z is 2.34, and then it gives you p-value and critical z's for both one tail and two tail. And based on your research, what you had decided you were conducting the test on, you need to decide whether to use the one tail value or the two tail value. Again, in our example, we were interested in seeing whether there's a difference or not between the salaries of registered nurses and non-registered nurses, and we can so we had a two-tail test, and based on that we can see that our calculated value, calculated test statistic is greater than our critical z value for two-tail, and therefore we can reject the null hypothesis that the two salaries are equal. We can also look at the p-value. The p-value for two-tail test is 0.01, which is smaller than the p-value, the alpha 0.05 that we had selected. So again, we can reject the null hypothesis and say that based on these two samples, we don't have enough evidence to think that
Okay, so again, as I mentioned earlier, no, that this test, no, for a difference in proportion. So a two proportion z-test allows you to compare two proportions to see if they are the same. So the null hypothesis for the test is that the proportion are the same, and the alternate hypothesis is that the proportion are not the same. Okay, that's it. Thank you, and good day, everyone.